Section 8.2, Perimeter and Area. In this section, we will talk about finding the perimeter and area of different shaped polygons. Before we begin, let's review a couple of key vocabulary words that you need to know. First of all, a polygon. A polygon is a closed figure with three or more sides, with each side being a straight line segment. So, if I were to give you something like this, the way I have it drawn right now, is not a polygon. It does have three sides that I tried to make as straight as possible, but it's not closed. By closed, I mean that I would need to close it up so I have an inside. Now, this is a polygon that I have drawn. There are several polygons that are very typical polygons that we will be dealing with in this section. And I just want to talk about them here very briefly. You know that a square is a four-sided shape with all four sides being exactly the same length and having four 90-degree angles. So this is a 90-degree angle, this is a 90-degree angle, this is a 90-degree angle, and that is a 90-degree angle. Another common polygon is a rectangle. And a rectangle is a polygon, four sides. Once again, it has four right angles to it, and the opposite sides are the same length. Sometimes the way to show that the opposite sides are the same length, you might have little dashes. Those two dashes indicate that those two sides are the same length, and if I did the same thing with the other opposite sides with two dashes, that shows that those two are the same length. So that is a rectangle. Another common shape that you will see in this section is a parallelogram. A parallelogram is a four-sided shape, and this four-sided shape, the opposite sides are parallel to each other. In addition to the opposite sides being parallel to each other, the opposite sides are also the same length. And I'm going to indicate that by putting in those notches again. So parallelograms, the opposite sides are parallel, the opposite sides have exactly the same length. One other thing to notice is that they do not necessarily have 90-degree angles. This is not a 90-degree angle. This is not a 90-degree angle. Nor is that, nor is that. One other thing to notice about all of these is that all of the shapes that I have drawn here have four sides. Any four-sided shape is given a name, and the name is a quadrilateral. And the easy way to remember that is quad means four. So all four shapes on there are quadrilaterals, but there are particular types of quadrilaterals known as the square, the rectangle, and the parallelogram. I also want to briefly mention triangles. Triangles is another type of polygon because they have at least three sides and all the sides are straight. It's a closed figure. There are certain types of triangles, and where you do not need to memorize these at this point, but I do want to mention this. The triangle that I've just labeled number 1 is known as a right triangle. It is a right triangle because one of the angles is a right angle. The triangle that I've just labeled number 2 is known as an acute angle because all the angles that you see are acute angles. So that is an acute angle. The first one, as I said, is a right triangle. The second one is an acute triangle. Number 3 is known as an obtuse triangle, and the reason it is an obtuse triangle is because one of the angles is obtuse. It is greater than 90 degrees. Once again, you don't need to memorize these for this section or anything, but I do want to point that out because you will see these different types of triangles as we're working through this section. The word perimeter means the total distance around the outside of a polygon. So I have a rectangle drawn here, and you can see that I have some dimensions for this rectangle. The bottom is 8 feet. One of the sides on the right-hand side is 3 feet. Now, because it's a rectangle, that means obviously that the top of this rectangle is also 8 feet long, and the left side of it is 3 feet long. If perimeter means the total distance around it, I just need to add up all those numbers. So, one thing I can do is I can just start at one corner and I can go all the way around. And if I do that, I could just add up the numbers, 8 plus 3 plus 8 plus 3, to find the total perimeter. And if I add all those up, I'm going to get 22. I just need to make sure I label it with the correct unit of measurement. It's 22 feet. Now that's one way that you could go through and you could figure out the perimeter, but I do want to talk about some other ways as well. Rather than just adding up all those numbers, something else that I could do is I could just add up the width and the length, the 8 and the 3. So I could just add up the 8 plus the 3. So if I add up the 8 and the 3, I know that's equal to 11. Well, that is halfway around. So then I could just double the 11 or multiply by 2, and once again I would get an answer of 22 feet. Another way to go through and get the answer is to notice that I have two 8-foot long sides. So I could say 8 times 2, and then notice I also have two 3-foot sides, plus 3 times 2. 8 times 2 gives me 16, 3 times 2 gives me 6. When I add up 16 plus 6, I get 22 feet. So it doesn't matter which way you go through and figure out the perimeter when you have, for instance, a rectangle like this. It doesn't matter whatever way makes most sense to you, you can go through and do. Once again, make sure when you do it that you also give the correct unit of measurement there. In this case, it is feet. Sometimes you might be asked to find the perimeter of shapes that are not squares or rectangles or parallelograms or triangles, and this is an example of that type of shape. But once again, all perimeter means is the distance around. This happens to be what's known as a pentagon because there are 5 different sides to this. So if I wanted to find the perimeter, all I would do would be to start at one particular spot and go all the way around, and I would add up all the numbers. So I would just be adding up 10 plus 9 plus 9 or plus 8 plus 8 plus 9. Now once again, I might want to do this a little bit faster. I see I have 2 8s, and I know 2 8s is equal to 16. I have 2 9s, I know that's equal to 18, and then I have my 10. So if I add these up, I'm going to get 44, and once again I need to label, it would be 44 centimeters. Area is the amount of space inside a closed figure. And you can see that I have drawn a closed figure, a quadrilateral, a rectangle, and I have put down the dimensions of the sides. It's 7 centimeters by 3 centimeters. I did this on graph paper just so you could see exactly what it is I'm talking about. Notice I want to know how much space there is inside this figure, and I have it divided up into squares. So I could go through and count. There are 3 rows of 7, but it is much easier to just multiply, in this case, the length times the width. 7 times 3 gives me 21. So the area of this is 21, but I cannot just say it's 21. I have to say it is 21 square centimeters, because every square inside there is a square centimeter, and there are 21 square centimeters. It is very important when giving the answer to the area of every figure that you include the word square in every single one of your answers. It's going to be square centimeters or square feet or square miles. It just depends upon what label is used or the distance of those different sides. So the easy way is just to multiply the length times the width when you have a rectangle or if you have a square. I'm going to draw a square here. It might not have the greatest straight sides here, but if I draw a square that's going to be 3 centimeters by 3 centimeters, I know that's a square. So for this one, I'm just going to multiply 3 times 3. I will have a final answer of 9 square centimeters for the area of that square. Let's talk about finding the area of a parallelogram. Some people have said that a parallelogram kind of looks like a rectangle that's leaning, and it is in many ways. As a matter of fact, you can take a parallelogram, and let me do this right now. If I were to cut off this section right here in red, if I were to cut that section off, and if I were to put that same section and move it over to the other side, you would see that it would fit exactly in there. I have exactly the same thing. Now what I'm going to do is I'm going to pretend this isn't here, and I'm going to trace in green really what my new shape is. It's a rectangle. Because it's a rectangle, the formula for figuring out the area of a parallelogram is very similar to the formula for figuring out the area of a rectangle. Before I continue, I want to go through this again in blue and show you what we had. This is what we had from the very beginning, and now this is in blue, so forget about all the green lines there. Notice that the length of one of the sides, also known as the base, is 1, 2, 3, 4, 5, 6. The length of one of the bases is 6. The height of that particular parallelogram is 3. 1, 2, 3, if I were to go straight up. So, if I just multiply the base times the height, I am going to get the area of a parallelogram. So this would be 18 square centimeters again. Notice that all I did is I found out what the base was, and then I found out what the height was. What's important when finding out the height is that the height goes straight up from the bottom. It's not the slant, because this is on a slant, so the distance of that side is going to be larger than 3, because if I were going to move this over, if I was going to take that side and if I was going to make it go straight up, it would go a little bit further than that. So once again, in order to find the area of a parallelogram, you are going to multiply what's known as the base times the height. Let's do another one. Here's another parallelogram, and you can see that I have it drawn in, but I have not given any of the measurements. But I know that the base, the bottom of this, is 3 centimeters because I can count the number of squares that it is going across. Now I need the exact height. The exact height is that distance going straight up. So the distance going straight up is 2 centimeters. So the area of this would just be 3 times 2, which would give me 6. And once again, I need to say square centimeters for the labeling part of my answer. In your homework, you'll have to do some problems finding the area of a parallelogram without it being on graph paper. So let's take a look at an example like that. Here I have a parallelogram again, and it looks like the base of this parallelogram is 10 centimeters. Notice that the one slanted side right here is 36 centimeters. But once again, that's not the height of this parallelogram. The height of this parallelogram is 30 centimeters because it goes straight up from the base. So in order to find the area of this, I would be multiplying 30 times 10. 30 times 10 gives me 300, and my final answer would be 300 square centimeters. While we have this, remember though that you could go through and find the perimeter of this. perimeter is the distance all the way around. So if I wanted the perimeter of this, it would be 10 plus 36. 10 plus 36 would give me 46, and I have to go another 10 and 40 and 36. So I would just be adding another 46 to that, or I would be doubling that. 6 times 2 gives me 12. 4 times 2 gives me 8, plus 1 gives me 9. So this would be 92. And once again, it would just be 92 centimeters. It's not 92 square centimeters. You use the word square when you're giving the answer to an area problem. Let's turn our attention to finding the area of triangles. You can see once again I've drawn a triangle here. This happens to be a right triangle because there is a right angle right here. And as I want to find the area of this, I've put this on graph paper. And once again, I put this on graph paper because I want you to see something. Notice that if I were to go through and change this once again into a rectangle, the area of that rectangle would be, because this is 4 centimeters by 3 centimeters, the area of the rectangle would be 12 square centimeters. Well, when I take a look at that triangle, I see that that triangle is exactly half the size of that rectangle. So in order to find the area of this triangle, what I need to do is I just need to multiply, once again, the base times the height, but whatever I get, I need to divide it by 2. So I'm going to multiply 4 times 3, but whatever I get, I'm going to divide it by 2. Well, 4 times 3 gives me 12. 12 divided by 2 gives me 6. So the area of this triangle, once again, is 6 square centimeters. Remember, I have to have the word square whenever I am giving the answer to an area problem. Here's another triangle that we need to find the area of. We're going to do exactly the same thing. I'm going to take this triangle and I'm actually going to construct a rectangle out of it. So if I construct a rectangle out of it, the area of that rectangle would be 1, 2, 3, 4, 5, 6. The base is 6 centimeters. The height is 2 centimeters. 6 times 2 gives me 12. So the area of that rectangle would be 12 square centimeters. But once again, I want you to notice that that triangle that I have is exactly half of that rectangle. If I were to take this section right here, that is exactly the same as what I just outlined in the green. Same thing if I did the other side. That is exactly the same as that. So what I have is my triangle is exactly half the area of the entire rectangle. In order to find the area of a triangle, the formula is the base times the height, and then whatever you get, you're going to divide it by 2. So once again, 6 times 2 gives me 12, but I need to divide that 12 by 2, so I get 6 square centimeters for the answer. Here's an example of a triangle that's not on graph paper, and you can see that I have given you the lengths of all the sides. The bottom is 8 centimeters and the two other sides are 7 centimeters and 5 centimeters. I've also given you the height of this triangle. The height of this triangle is 4 centimeters. In order to find the area of this, I'm going to need to multiply the base times the height, and then whatever I get, I'm going to need to divide that by 2. Well, the base is 8, the height is 4. 8 times 4 gives me 32, but then I need to divide that by 2. So the area of this triangle is 16 square centimeters. Once again, let's just review perimeter. Remember, perimeter means the distance all the way around. So in order to find the perimeter, I would just be adding up the 7, the 5, and the 8. 7 plus 5 plus 8 gives me 20. So the perimeter of this would be 20 centimeters. To review, please remember these two formulas for finding the area. To find the area of a parallelogram, you just multiply the base times the height. Just make sure it's the straight height going up, not a slanted side. For the area of a triangle, it's the base times the height divided by 2. If there's anything that I can do to help as you work through the homework in this section, please let me know.